Welcome. We're jumping right into day 2 of the 5-day Google Kaggle course on AI agents. And today is a huge one. We're talking about agent tools and interoperability, basically how we give AI the ability to actually do things in the world, and how we get them all to speak the same language using something called the Model Context Protocol, or MCP. So here's a quick look at what we're covering. We'll start with the why, then get into the how-to of building great tools. Then we'll get into MCP, the big problems that come with it, and finally, how we can build this future securely. All right, let's dive in. First up, why do agents even need tools? I mean, these models are super smart, right? Well, yeah, but tools are the absolute key to turning them from a fancy text generator into something that can actually take action. Think about it this way. At its heart, an AI agent is all about reasoning and achieving goals. But without tools, it's trapped by its training data. It has no idea what the current stock price is, it can't access your calendar, it can't do, well, anything new. I love this analogy because it just makes so much sense. The model is the brain, right? It's doing all the thinking and the planning. But without tools, it's like a brain in a jar. Tools give that brain hands to interact with things and eyes to see what's happening right now. Okay, so if we're giving our AI brain hands and eyes, we have to make sure they're, good ones. It's not enough to just throw a tool at an agent. You have to build it in a way the agent can actually understand and use reliably. And it turns out there's a real art to this. We're already seeing a few key best practices pop up. Things like focusing on what a task achieves, not just the raw code, documenting everything clearly, making tools that do one thing really well, and making sure they don't talk the model's ear off with huge outputs. And this slide right here, this is so crucial. You have to remember, the AI never sees your actual code. All it sees is the documentation you write for it. On the left, it's just guessing. On the right, it knows exactly what the tool does, what it needs, and what it will get back. It's the difference between failure and success. Now, this is a big one. You've got to avoid something called context window bloat. If your tool dumps a giant wall of text back to the model, it just clogs up its short-term memory. It's expensive, it's slow, and it actually makes the model dumber. So instead, just give it a quick summary, or even better, just a link to the full data. Okay, so we know how to build one good tool. Fantastic. But what happens when you have hundreds of different agents that need to use thousands of different tools? That's where you hit what's called the N by M problem, and it's a total integration nightmare. This is where the Model Context Protocol, or MCP, comes in. I mean, just look at this mess. This is what happens without a standard. Every time you add a new model or a new tool, you have to build a custom bridge. It's a spaghetti monster of connections that's impossible to manage. MCP is designed to be the one universal bridge that replaces all of this chaos. So how does it work? It's actually a pretty simple client-server setup. You have the host, which you can think of as the traffic cop directing everything. You have the server, which is like the workshop where all the tools live. And you have the client, which is just the messenger running back and forth between them. And the secret sauce that makes all this communication work is a standard called JSON RPC 2.0. Now, don't let the name intimidate you. All it really is a super simple, universal message format, like a text message that any programming language can understand. This means your Python app can talk to a Java tool without any problems. It's all about interoperability. Okay, a universal, plug-and-play standard sounds amazing, right? But, and you knew there was a but, when you create something this powerful and open, you also create some really big challenges, especially around performance and, you guessed it, security. We talked about context window bloat before, but at a massive scale, this problem gets so much worse. You just can't stuff the instructions for hundreds or thousands of tools into the agent's brain at once. It would be incredibly slow, cost a fortune, and the model would get so confused it wouldn't be able to think straight. So, the clever solution here is to change how we think about it. Instead of preloading everything, the agent first does a super fast search, kind of like a Google search, to find just the handful of tools that are most relevant for the job at hand. Then, it only loads those few into its working memory. It's a game changer. But performance is only half the story. There's a much bigger, scarier problem: security. And a standardized protocol like MCP can open the door to a classic cybersecurity attack that's found a whole new life in the world of AI, the confused deputy. So here's how the sneaky attack works. An attacker with low permissions tricks the AI with a malicious prompt. Now, the AI is our confused deputy. It's trusted, so it doesn't question the command. It just passes the malicious request along to a powerful tool server. The server sees the request coming from the trusted AI and says, "Okay, you got it," and executes the command, letting the attacker do things they should never have been allowed to do. Okay, that is pretty scary. So how do we move forward? How do we build this amazing, interconnected future of AI tools without opening up these massive security holes? The answer brings us to what is probably the single most important lesson of this entire session. If you remember one thing, make it this. MCP itself is not the security solution. The security has to be built around it. The answer isn't to reinvent security from scratch. It's to wrap MCP in layers of armor using the exact same robust, enterprise-grade security tools we've been using for years. We're talking about API gateways for authentication, strict allow lists, detailed logging, and, this is a big one, never, ever putting passwords or secret keys where the agent can see them. So let's bring it all home. The bottom line is this. MLCT is the universal translator that lets all the tools and agents talk to each other. It enables the ecosystem, but it is not the security guard. It's up to us, the builders and the enterprises, to construct the secure fortress around it to make sure it's used safely. And this leaves us with one final, very deep question we all need to think about. If a user tells an agent to delete everything in the project, should it? Or should it understand that the user's intent is to clear out old files, and that they're only authorized to touch their own work? Building agents that can tell the difference between a literal command and an authorized intent, well, that's the next great frontier for building an AI future we can actually trust.